Howdy guys, welcome to another stats video. It's our second day of confidence intervals for proportions. Those are known as one prop Z intervals because we're using one proportion and we're using a Z interval. We'll talk about the difference between a Z interval and a T interval next time. But one proportion Z is only valid if we know that the normal distribution, which is the Z distribution, can be used. The set of all sample proportions needs to be approximately normal. This will happen if we have at least 10 successes and failures in our sample. So the first example says, Mr. Trenfield went to the gym to shoot free throws. He made 9 out of 10. So our p-hat, what's right here? Our p-hat is 9 out of 10, or 0.9, and our n is 10. Okay. Construct a 95% confidence interval for his his free throw percentage. So we can use that bookmarked website from last class to come up with this interval. Oh no. We're talking about the probability of him making a shot and it goes over 1. That's no good. For a confidence interval for proportions, to be valid, we need to have at least 10 successes and 10 failures. And we didn't. We had 9 successes and 1 failure. That's why this interval was jacked up. This confidence interval said that he had a true percentage of hitting free throws between 71% and 108%. Definitely not, right? Almost 109%. The next example, last year, Lonzo Ball made 41.7% of his free throws. Lonzo's dad says Lonzo is a better free throw shooter now, and this season so far, he's made 19 out of 37 free throw attempts. Can we say with 95% confidence level that Lonzo's free throw ability has improved? Well, what's p-hat? That's 19 out of 37. Okay, have we had at least, well, let's see this. That's about 0.5135. 19 successes and 18 failures. Where did 18 come from? That's 37 minus 19. That's how many times he failed. So we definitely have 10 of each. We're going to call this a one prop Z test. Sorry, it's one prop Z int, meaning one proportion Z interval. Like we've been figuring out, 0.3524 is what this ends up being. 0.6746. And if you want help with how did I go from this information to get this interval, watch the last video, right? Because I explained with the bookmarks that I have under last class. So, is he better? Well, 41.7% is where he was last year. That's still in this confidence interval, so we're going to say no. 0.417 is still within a 95% confidence interval. It is possible he has improved, but we need more data. Okay. So, sure, he could have gotten better, but based off of this, this proportion, this 19 out of 37, that's not enough to say that he's better than he was last year. Man, I apologize if that was in your ear. It snuck up on me. Okay, a recent poll showed that 70% of Americans support Medicare for all healthcare system. The poll had a margin of error. This comes from, well, this poll down here. It's off the screen a little bit. This guy. The poll had a margin of error of 3.1% and a confidence level of 95%. What's the sample size of this poll? Well, so in general for a confidence interval, for proportions, it's p hat plus or minus z star. It's kind of review from last class. Times the square root of p hat times 1 minus p hat over n. Well, n is the sample size, always. P hat here is 0.7. Z star is, for 95% confidence level, it's 1.96. Again, on the notes from last class. Okay. They tell us that the margin of error, I'm just going to use this abbreviation, is 0.031. It's kind of smushed in there, and let's do this. It's a little better, easier to read. Okay, so I'm going to build this guy. Remember, this is our margin of error. So we know this guy is equal to 0.031. We know what z star is. We know what p hat is. Okay, so we'll divide on both sides by 1.96. We're just solving this for n. It says what's the sample size for this poll. That's all we need to know. So once we divide by this, we're going to square both sides. And Desmos can do this all at once if we're just kind of careful about how we do it. So let's see. We're going to have 0.031 over 1.96 squared. Over here, the square is going to kill the square root. And we're going to be left with 0.21 over n. I'll multiply on both sides by n. And we're going to divide on both sides by this nastiness. 0.031 over 1.96 squared on both sides. So those are going to go away, and we're going to divide it by 0.031 over 1.96 squared. So n is going to be 0.21 divided by this square. N is 839.47. We're always going to round up when we're finding sample size. So N is going to be 840 people. All right. Last example, and then there's a couple for you guys to do for practice. Dr. Cruz wants to poll Austin High School students about lunch options. How many students does he need to, I don't know what this is, part of the deal, I guess. How many students does he need to poll to have a margin of error of 1% using 90% confidence level? So sample size is 1 times 1 minus, times p hat. Okay, since the poll hasn't happened yet, and this will happen sometimes. We have no p hat. So we're always going to use the most conservative value of p hat we can find, which is 0.5. That's going to maximize, this is worst casing, the margin of error. Okay, the larger p hat is the closer it is to a half or 0.5, the bigger the margin of error is. So this is our formula. So what I did is I took margin of error equals this, and I rearranged it to solve for n. You don't have to do that, but you can, and if you did, you would get this. So I'm using the same equation we used in the last problem. In fact, you can see this is margin of error divided by z star squared, and this is p hat times 1 minus p hat. It was 0.7 times 0.3, I think. Yeah. So you don't have to rearrange this, but this is coming from using the same equation we used up there. Just rearrange it because we're looking for n. We could have done that last time too if we wanted to. Most of the time we'll use this if we know the margin of error and need sample size. Just a little bit easier to substitute these in and simplify than it is to rearrange like we did in the last one. Okay, so I'm just substituting in the values they gave us. The margin of error is 0.01. Z star for 90% is 1.645. That's on the notes from last class. 6765.06, which is going to round up to 6766 people. I think let's make the units up here people too. I think every time we do this, we should have units here for sample size, because it may be, rockets or baseballs or whatever, but there should be units for our sample size. Okay, if there's something you didn't understand here and it was based on where'd you get that Z star from, that kind of stuff, check last video. But if you still have questions, come to tutoring and I can help you.